Hello everybody, my name is Patrick Langa and I'm the host of today's webinar. Today together with me are Dr. Anthony Hartel, our panelist, and Mr. Cesar Rangel. Cesar, can you show up with your camera? Absolutely brilliant, thank you guys. Warm welcome to everybody.
Okay, thank you so much. Thank you for the invitation to this webinar. I hope you will enjoy and learn about our experience at Cenipalma, Colombia. Now this is the content of the next presentation. I will talk about a brief presentation about Cenipalma and Colombian Oil Palm Guild. Then Fedepalma and Cenipalma, one organization, one federation. Next, Colombian oil palm agro-industry circular economy. Then gap between oil losses and process quality in palm oil mills. Then quality parameter measurement methodologies used at palm oil mills and oil refineries. And then timeline of Cenipalma and Büchi agreement. Then Cenipalma technology for parameter analysis, NIR. And then results of the first phase in laboratories of Cenipalma. The next one, results of the second phase in laboratories of palm oil mills. Then advance in the construction of the transfer function between NIR instruments. And then closely the gap between oil losses and oil extraction at palm oil mills using NIR technology, economic opportunity. And finally, the first part, conclusion and origin of technologies in Colombian palm oil industry. A brief presentation of Cenipalma and Colombian oil palm mills. We have an overview of palm oil production in the world, where Indonesia are the main countries with higher production, about 62 million of tons of CPO between both Asiatic countries. Colombia is in the fourth position with 1.6 million of tons of CPO, the first country in America with a higher production. These are some key indicators of palm oil in Colombia. Second. Okay. 2.3% of the world production. For the last year, the production volume was $1.2 million. Colombian oil palm export the half of its production. This agro-industry contributes on 11% of the for the agricultural GDP, or gross domestic product. Colombia has 530,000 hectares with oil palm crops. There are about 70 palm oil mills across the country. This crop is distributed on 4 geographical areas in Colombia. Let's talk about the Fedepalma and Cenipalma as one organization, one federation. Fedepalma is the Colombian organization for oil palm growers. In other words, they are the guild representation. Cenipalma is the oil palm research and innovation organization. In other words, we are the scientific and technical for the guild. Fedepalma and Cenipalma, we are one organization, like a chimera, with 2 DNAs on one person. We have a support service and resources like infrastructure and laboratories, administrative resources, etc. We give support, guidelines, technical and scientific innovation, new technologies, recommendation in front of government statements for the plantation, palm oil mills, and oleochemical refineries. We have been staying in the Colombian Guild for over 25 years. And this is the circular view of Colombian oil palm agro-industry, called the circular economy. Everything starts at the field with the oil palm plantation. When the fresh fruit bunches are harvested and then they are transported to the palm oil mill or pump. In the palm oil mill, the fresh fruit bunches are processed just with mechanical and thermal systems. Then they are extracted 2 main products, crude palm oil, CPO, and crude palm kernel oil, CPKO. Once these oils are refined, they are used as edible oils, biodiesel for pharmaceutical uses, for animal feeding, and great variety of use. For example, the soaps for hands and body and detergents for cleaning are made with palm oil. These are the powerful weapon against the COVID-19 virus. The biomass are obtained while the fresh fruit bunches are processed. They appear the empty fruit bunches, fiber, shells, kernel, biochar, and effluents. These byproducts have other special uses like power generation, special filters for wastewater, compost, etc. At the research program where I work, we have a lot of investigation about all this circular economy. If you want more information, please let me know. From the point of view of economic profits and industrial performance, there are a gap between oil losses and process quality in palm oil mills. There are 4 steps on the production agro-chain. It starts at the plantation with the fresh fruit bunches, then continues with the oil CPO and CPKO with other byproducts at the palm oil mills. Then the oils are processed at oleochemical refineries to obtain the last products for commercialization lines around the world. For closing the gap between benefits and losses, the market and the customers make requests about nutritional content and contaminants to the palm oil refineries. Then the refineries make requests to the palm oil mills about quality parameters for CPO and CPKO. Finally, the palm oil mills make requests to the plantation about fresh fruit bunches quality. We have a research project for oil extraction rate online monitoring using a new technologies with neurline sensor of BUCHI. If you want more information about this project, please let me know. The palm oil mills measure the quality by an analytic method to obtain parameters like moisture, free fatty acids, Dobby, and other parameters that can be used to control the oil production. One of these parameters is the oil losses measured by on the byproducts like the pressed cake or CPO or CPKO, empty fat bunches, processed slugs, fiber, shells, kernel, and effluents. But the conventional oil loss methods have a lot of disadvantages. The time, the palm oil mills have to wait for 4 or 5 hours to have just one result of oil loss. This is by Sutlet equipment, a conventional method. Just measure a mixed sampling of all day, so they lose all the statistical variability of all fresh fruit bunches that was processed. These conventional methods requires the dangerous and controlled substance like hexane, petroleum ether, etc. At the end, the process can be controlled by the conventional methods, so the production costs increase, the industrial productivity decrease, and the result is the decreasing of the economic profits for the palm oil mills. This is some of the quality parameters measurement methodologies used on palm oil mills and oil refineries. The Colombian palm oil mills have used different methods created and adapted by Cenipalma. Other procedures like oil losses came from other standards like CNL, moisture, and volatile materials for AOX. Cenipalma have compiled a laboratory procedure manual for Colombian palm oil mills, considering other resources like MPOB, Process Handbook, Malaysian Palm Oil Board. The timeline of Cenipalma and Büchi agreement start on 2016, where both organizations make agreement after International Conference of Palm Oil at Cartagena, Colombia. That was on 2015. The next 2 years, together with Leonardo Ramirez and Natalia Forero, both researchers at Büchi, we begin the construction of the prediction models of oils, CPO, CPKO, and 4 byproducts. 2019, we start the validation of all prediction models of the palm oil mills in one of the oil palm geographical areas. These palm oil mills were Palmera de Puerto Wilches, Palma del Cesar, Extractora Monterrey, and Palmatra. That year, Palma del Cesar and the processing program of Cenipalma made a presentation at one of the Cenipalma key events called the National Technical Meeting. We won the first place on this event. thanks to this project. But our plans for the next year have a new challenge. I think it's for everybody. COVID-19. We're working with the biological protection protocols at the panel mills to continue with the research of new models like the cultivar identification, oil loss controls, new quality parameters, and other parameters for plantation like foliar and soil analysis. And this is the Spectral technology for parameter analysis, near-infrared radiation or NIR. In this project, we use two kinds of NIR equipment. The first one, the mathematical Fourier transform technology. In this equipment, a light emitted for a lamp gets a sample, and the optical phenomena like the transmittance, reflectance, and translentance are used to get the diffused light over a dispersive monochromator or moving with just one detector. The light measured by the moving detector represented on a special diagram called interferogram, then is converted by a Fourier transform to the spectrum response. On the other hand, on the dispersive technology, the moving detector and the monochromator are replaced by a 256 diode array. In other words, these are the pixels. Each diode of this system can catch a specific intensity in a range of the wavelength. Here in Colombia, we have a 3-NIR equipment of BUCHI, according to the research agreement. We have the NIRFlex N500 that uses the Fourier transform. This equipment can be used in more demanding laboratories with high resolution, for example, refineries and oleochemical companies. Also, we have the ProxiMate sensor. This equipment can be used on laboratory or in process application, especially for production monitoring, suitable for resolution for a plantation, panel mill, or refinery. Also, we have the NIR online sensor. This equipment is integrated in a project for online monitoring of oil extraction rate of each fresh product bunches supplier. Also, we can control the oil water dilution and get other benefits related with the production optimization and process automation. This project will be an important tool between plantation and panel mills to get the continuous improvement. The panel mills and the plantation could know more about the variation across the time of the oil extraction rate related with specific parameters at field like weather condition, disease, plagues, soil, nutrition, and other conditions. And I think that this will be a key milestone of the Colombian panel agro-industry. If you find more information, please let me know at the end of the presentation. The results of the first phase in laboratories of Cenipalma starts with the construction of the prediction model for CPO and CPKO, also by the byproducts. With Natalia and Leonardo, we work on the NIR translentance and cover characterization, considering the surface and other physical characteristics of the products and byproducts. Of this research helps to BUCHI for improvement, one of the most important accessories of NIR equipments. Then we make a principal component analysis, PCA, for identification of oil palm cultivar according to the country. We build an initial model that shows a statistical difference between Colombian fresh-fruit bunches respect to the Malaysian cultivars. Blue dots are information of Colombian fresh-fruit bunches, and red dots are from Malaysia. The statistical variance of 98% could explain the difference between both materials. The last product was the PCA for cultivar identification by generical material. This analysis showed that it's possible to know the oil palm material classification for oleifera, hybrid, guinensis, and Cameroon material. This model needs more samples for increase. The reliability, it will be another project in the future. The results of the second phase in laboratories of panel mills show the results obtained at the 4 pilot research panel mills. NIR equipment were used in laboratories, and NIRFlex N500 was used in Palma del Cesar, and ProxiMate was used in Palma de Puerto Wilches, Monterrey, and Palmata. We started with teach and practice using technology to technician engineers at the pan oil mills. The teaching and training process for the laboratory personnel took approximately 1 day, just 1 day. We can see how to organize the oil and solid samples on Petri dishes. The reference calibration adjustment process just takes 10 minutes by day. The POMs make the reference calibration process just 1 time per day. And once the technician makes the first calibration of the day, the samples can be read by the NIRFlex 500 or NIRFlex, spending just 1 minute. The operator selects the prediction model. In this case, was MP fruit bunches, and the properties were moisture content and oil loss. The process takes just 5 minutes, and the sensor is ready to make more readings across the day. In some cases, it's necessary to use a transference cover designed by BUCHI, especially if you are going to analyze liquid materials like CPO and CPKO. We make a validation the first prediction model in the 4 pan oil mills, and the result is the next table for oils and solid byproducts, components of Guinensis oil palm cultivar. This is the more popular generic material of the oil palm here in Colombia. The liquid models as CPO and CPKO have the parameters of moisture, free fatty acids, DOBI, and oil impurities. For solid products, there are quality parameters like moisture and oil losses. The calibration statistical indicator shows a good performance for all good models, higher than 70%, including the final validation exercise. It's important to clarify that the reference methods like SOSLET and other indicators in the AOX standard method must exist because this kind of technology always requires some verification method, but just once per week, once per month, once per year, according to each palm oil mill scenario. We also validate the models for a hybrid oil palm cultivar, and the result was this table for liquid and solid components. Some models are still under construction due to COVID-19 situation, and the correlation coefficient are higher than 70%. We have other statistical indicator for tracking the performance of prediction models according to the calibration and validation process. At the beginning, we found difference between cultivars and Guinensis hybrid, but at the end of the last year, we use a new prediction models that can integrate both statistical variabilities. Hybrid cultivars have a different configuration according to the free fatty acid profile and other biochemical parameters. Then we are working on a valuable tool for NIR technologies data conversion. We are developing an initial transfer function to migrate the prediction model between NIR technologies, ProxiMate and Flex. But in the near future, those who have an NIR ProxiMate equipment could use previous models for another NIRFlex or from a NIR online, and vice versa. It will not necessary to calibrate from zero. It will optimize time and resource for the pan oil mills or refineries. This tool of conversion will be an important key for the other projects like the online monitoring of oil extraction rate by fresh fruit bunches suppliers, because we could get a lot of information like DOBI, free fatty acid, loading index, and other parameters that could reveal information, great information about plantation and nutrimental composition, weather, disease, etc. And this is I'm closing the gap between oil losses and oil extraction at pan oil mills using NIR technology, economic opportunity. For a Colombian pan oil mill with production time of 24 hours per 24 days, a pan oil mill with 3 CPO press machines with a total capacity of 30 tons of press bunch per hour and 1 CPKO press machine. If this scenario just increase the oil losses on just 1%. The economic losses by day will be $526 on all machine of this scenario for CPO pressing and NCPO pressing machine. At the last day of the month, this panel mill will have lost $12,627. Using NIR technology, we could take more samples of pressed cake at pressing machines of CPO, CPKO. Each 15 minutes, for example, or 10 minutes, or half hour, with more frequency different to the conventional method of Soslet, where the result will be ready after 4 and 5 hours. Each sample will be analyzed by the NIR ProxiMate on 1 minute plus the preparation time of the sample on the Petri dishes, could be 3 or 5 minutes. The increase of resolution, data reliability, time response, and frequency of sampling is the most important things to do a real process control at an oil mill. On this scenario, the pan oil mill could have a payback time of months, and oil losses monitoring will allow timely decisions. The economic impact of oil losses will be considerable and measurable with high resolution. And the first part, conclusions and new of technologies in Colombian pan oil agro-industry. Thanks to the agreement between Cenipalma and Büchi, the Colombian pan oil mills have been able to experience technology management by their first hand. NIR technologies are one of the best alternatives to control the process at pan oil mills. The best alternative of pan oil mills is the NIR ProxiMate equipment. This equipment should be used in laboratory or industry areas. The Colombian pan oil industry is beginning to recognize the benefits of the Spectral technologies, especially to monitor oil losses. Obtain multiplier response parameters through an analyzed sample has been one of the most competitive advantages of the NIR technologies. The future application of NIR technologies in the agro industry are diverse. Even the plantation want to have access to this kind of equipment to achieve continuous improvement together with the pan oil mills. Also, we have another parameters for prediction models like DOBI and oil impurities. This is a list of the actual parameters that could be determined by the NIR technologies, as oil content, moisture, verified axis, DOBI, and oil impurities. And we are working updating other parameters like loading index, anisine index, peroxide index, color, carotenoids, phosphorus index. Another analysis on their study is the Meganium prediction model about the oil potential for raw fruit crushed for guineensis and hybrid cultivars. In process of research the next 2 or 3 years, could be we could make a new models about boiling treated water, effluents, soil analysis, and foliar analysis. This is we have published a scientific paper about this project that you could read at this URL. This document is called NIR technology for pan oil mills, optimization of quality of fruit of oils and byproducts to take a strategic decision during the fruit processing. At the end of the presentation, we could put the URL at the chat. And the team Cenipalma and Büchi for research. Cenipalma researchers, Cesar Diaz, Jesus Garcia, he's my boss, the research program leader about processing at pan oil mills. My partner at laboratory and chemical analysis, Alexis Gonzalez. Our partners at Büchi, they are developers and specialists. Natalia Forero, specialist of the development of NIR prediction models, and Leonardo Ramirez. Polco, distributor and technical support of Büchi for Colombia, and thanks for the pan oil mills in Colombia. Thanks for your attention. I will let you with the Anthony slides.
Okay, Well, thanks very much, Cesar. It's really interesting to see some of the results that we got when we applied NIR to your industry. And I think one of the highlights for me was actually the practical application to the oil mill. It was really interesting to see some of the savings you were able to make on using the NIR results. Now, I think you've touched on it during some of your presentation. I was really going to start to talk about some of the hardware that we used during the collaboration, just to clarify things to perhaps the audience that are out there. Now, if after the webinar you decide to go to the BUCHI website to have a look at the NIR instrumentation, these are the 3 BUCHI NIR instruments that you'll be able to find on our web pages. There's the NIRFlex M500, the ProxiMate, and the NIRMaster. So first of all, we've got the NIRFlex M500. What's the difference between the two? Well, primarily the NIRFlex M500 is for work in the laboratory. And in the case of the palm oil industry, it's really for working in the palm oil laboratory. It's quite an interesting instrument. It's got a modular design, and that allows you to use different ways to present the samples to the instrument. And really, these have been designed for, in particular, QC and R&D type of users. Now, the NIRFlex M500, as Cesar mentioned in his presentation, is based on FT NIR technology. And so it gives the very highest level of NIR performance, the highest levels of wavelength precision and repeatability. And in turn, this actually gives you the very best performance from applications, giving you the very lowest levels of errors in your when you use those applications to measure things like moisture, free fatty acids, and oil loss, etc. The other instrument that Cesar mentioned is the ProxiMate instrument. And the main difference here is that the ProxiMate is designed to be used, it can be used in the laboratory environment, but it can also be used in the production area. It's designed to be particularly robust, and it's designed to be operated in challenging environments, right next to the production line. It also incorporates a really easy to use touchscreen, and the software there has been designed to be used in the most easiest way. It's also often delivered to our customers with applications preloaded. There's not often a need to set up the instrument, and it's able to be used with ready-to-use applications. And as I'll talk about in a moment, we have some specific applications that are designed for the palm oil industry and which have been developed in cooperation with Cenipalma and in cooperation with Cesar and his team in particular. So let's think a bit for a moment about the palm oil production environment. It's quite a harsh environment when we think about it. When we go into a palm oil production plant, it's very noisy. There's a lot of dust there in the environment, and there's quite a lot of vibration. And there's often quite high levels of temperature change and humidity changes on a day-to-day basis. As time goes by, a lot of dust and oil can coat the equipment that's in the palm oil production area. And to get rid of that, to clean the area, quite often the operators use robust cleaning agents to clean that dirt and oil off the equipment. In addition, there's heavy plant machinery present, and that's a really strong source of vibration for the equipment. And so when we take all of these things together, it creates quite a challenging environment for an NIR instrument to operate in. And if we think of older pieces of equipment that are out there for measuring NIR, they needed a nice, quiet, clean environment to be able to offer good, accurate NIRs. And so you can see that it's quite a challenging environment for the equipment to work in. Now, ProxiMate has been designed to work in these challenging environments. And if we think about this palm oil production environment in particular, we think about the challenges we have related to water, oil, dirt, and dust. We can see that actually the ProxiMate is actually completely sealed to the outside world. Dust, oil, and water can't penetrate the outer case. We've tested ProxiMate extensively, and it offers the highest level to ingress protection. It's been certified to a particular ingress standard called IP69, and that means that you can use high pressure water jets to wash the instrument, just like we can see in the picture on the right-hand side there of this slide. And so we're quite confident that actually the instrument can withstand the harsh conditions that the instrument will be subject to during its use. In addition, we've worked closely with some of the companies that produce these strong cleaning agents that are commonly used in food production, and including palm oil production areas, things like alkaline, chlorides, and acidic cleaners. And we know very well that we've tested the materials that we've used on the outer case of the ProxiMate instrument, and we know that ProxiMate's able to withstand all of these harsh cleaning agents with no deterioration to the casework, no deterioration to the instrument performance. In addition, like I said, there's quite often temperature changes when these palm oil production places. They're usually placed close to the palm oil plantations. And again, we've taken that into account during the design of the instrument. The internal optical bench of the ProxiMate is temperature stabilized, and that allows the ProxiMate to be able to operate over a wide range of ambient temperatures. So again, we're able to get good, accurate measurements from the instrument. Now, in addition to this, there's lots of things that you might want to measure in a palm oil plant, from oils through to fruit bunches and through to fiber and press cake. And in order to do that, we offer a range of different measurement geometries to be able to optimize the choice of measurement for those particular products. Both liquids and solids can be measured with ProxiMate, and we have special adapters. I think Cesar mentioned in his presentation, we spent a lot of time optimizing one of the accessories for, in particular, the crude palm oil measurement. We also have a range of measurement geometries. We can offer things like up, down view, or combined view instruments, and that they can be then chosen and tailored exactly to the user requirements. And you can see at the bottom of the slide, we also have a range of sample cups that allow the user to choose the best possible option for their measurements. And for example, in the bottom left there, we can see a ProxiMate being used to measure crude palm oil using a glass Petri dish with a dedicated transflectance adapter in up view analysis mode. In the middle of the slide, at the bottom there, we've got an example of a large sample carrier. A large sample cup, and that can be used with things like fiber measurements, where there might be some inhomogeneous distribution of things like moisture throughout that sample, and that allows larger sample areas to be analyzed by the instrument, providing more accurate results. And that would be used in down view. So you can see we have a wide range of measurement options available for customers working in the palm oil industry. In addition to this, we've designed the instrument to need minimal maintenance. ProxiMate features a very long life lamp, so that reduces the amount of user interface that needs with servicing the instrument. And even when the lamp does need replacement, the lamp is easily changed by operators on the ground. The instrument's designed for continuous use. It's designed to be left switched on continuously, 24 hours a day, 7 days a week. So it's always available for operators to maximize the value that you can get from the spectrometer during its time in front of the production environment area. In addition, it contains a Windows 10 PC, so it's really easy to connect to your company networks. It's just as easy as connecting a laptop or a standard desktop computer to the company network. So you're able, with the reports that you're able to generate with the instrument, you're able to export those to remote locations and to interrogate those on laptop computers or maybe desktop computers in other parts of the business. Now, as I think we mentioned, it's really easy to get started quickly, particularly in the palm oil industry. We offer a range of ready-to-use applications for final and intermediate products. In particular, at the moment, we have commercially available products for crude palm oil, fruit bunches, kernel cake, and fibers. And you can see the types of things that we offer as commercial applications straight away. And this means that when ProxiMate's delivered, you're able to get started quickly with these applications. Maybe it just needs very small adjustments just to normalize the measurements given by the ProxiMate to your processes and to your laboratory reference techniques. So you can see it's a really good way to get your NIR instrument implemented very quickly. Now, as you work with the NIR instrument, you might find that you develop your expertise and you want to develop your own applications with the data that you're getting out of the instrument to even further maximize the value that you're getting from the NIR investment. And we're able to do that using a choice of 2 calibration development tools with ProxiMate. We offer AutoCal and also the NIRWise Plus chemometrics suite. AutoCal basically uses advanced algorithms built into ProxiMate that mean that you only need to enter laboratory reference values to samples that you've already taken in the ProxiMate instrument. And a simple press on the screen allows the ProxiMate to optimize calibrations and applications within ProxiMate to your own laboratory reference analysis, allowing you to develop new applications. Now, you might have read a little bit more, may have developed your own expertise of NIR application building, and you may wish to take that further. It's possible to do that with the NIRWise Plus chemometrics suite. That can be used on a laptop or can be installed on the ProxiMate instrument, and that allows you to take data easily from the ProxiMate instrument and to develop your own applications and calibrations on maybe a laptop in your own office, and then import those into the ProxiMate instrument in the production area. So you can see there's full flexibility with these software tools and with the hardware options that are available. So really, just to summarize what I've tried to cover is, we offer 2 types of NIR instruments that are suitable for the palm oil industry. The M500 is for top of the line, high performance NIR, which is usually more suited to the laboratory environment. And you may find that if you develop applications and calibrations on that instrument, it's possible to port those out to ProxiMates that are based perhaps closer to the production line, where you can maximize the value you can get from those NIR instrument measurements. ProxiMate's very robust. You've got no worries when you implement the ProxiMate near to the production line, and it's been thoroughly tested for use in those areas. We've also offer a range of ready-to-use applications that help you get up and running very quickly, particularly with the palm oil industry. And as Cesar mentioned in his presentation, we're continually working to evolve and expand that range and that portfolio of applications over the coming months and over the coming time. And also, it offers you the chance, if you choose to become more experienced with NIR, there are a number of different options that allow you to develop your own applications and calibrations should you choose to do so. And I think the nice thing about that is it allows you to expand your versatility of the instrument to meet your own perhaps production environment, your own production parameters. Okay, so now we'll move on to the Q&A session.
So the first question we have here for the session is, what are the parameters in palm oil production that can be measured? And this is a question to Dr. Hartel.
Okay, well, that's a very wide-ranging question, isn't it? It's quite general. I think it's fair to say that the applications that we have currently available, I think I just touched on during the presentation, they cover things like crude palm oil, fruit bunches, fibers, mesocarp fiber, and kernel cake. And some of the parameters we have are free fatty acids, Dobby, dirt, oil loss, and moisture. These can be found on our applications finder, and I'll perhaps post a link to that at the end of the presentation. I think, Cesar, you also covered some of the parameters in your presentation, and there's a few more that are still in development. I think it's a shame there's a bit of a pause now with the COVID-19 situation, but I think there's more parameters on the way, and I think eventually we should have a full wide-ranging portfolio that covers the palm oil industry.
Thank you very much. And another question to you, Dr. Hartel. What are the main advantages of NIR spectroscopy over the standard laboratory methods?
Oh wow! Again, another quite broad and general question. I suppose there are quite a lot of advantages with NIR spectroscopy over the standard laboratory methods. I suppose things like reagent use would come into there, and probably some level of skill level that's needed by the operators. But I think that in my work, the main advantages that we'd see is the speed of the analysis, I think, and probably Cesar would agree with this. I think it's not just the speed of the analysis that's the key thing with NIR, but actually the fact that that allows you to take more analysis points during a given time. And that helps you to see more clearly what's going on with the production process and help you to make any corrections or maybe optimize that production process, because you have got a greater resolution of what's happening on the production process, I guess. So if anything, I think the main advantage to me would be speed, but it's not so much the speed that you can get results, it's the fact that that allows you to take more results over a given time.
Great, thanks a lot. Mr. Rangel, where has the NIR measurement had the greatest impact on improving the palm oil extraction process?
Okay, the high impact will be at the oil loss monitoring due to the high cost of the 1 ton of CPO or CPKO. It's about $400 per ton of CPO, and CPKO could be more or less. The oil extraction is the main objective of the oil palm mill with the maximum effectives as possible. So as all you can do about reading the oil losses with this kind of technology, you are going on the way to close the gap between oil losses and the oil extraction rate. I think that this is the key point of the oil losses.
Good. Thank you very much. And then another question to you is, how has knowledge of the other parameters described in the presentation helped you improve the oil extraction process?
Okay, at the presentation, and the second slide, I showed a scenario of oil losses monitoring on the slide about the closing the gap between oil loss and oil extraction, oil palm, and the palm oil mills using NIR technology, the economic opportunity. As I said, all you can do about the closing this gap, this is the way. I think that this is the real way to improve the oil extraction. If you one special advantage of the NIR technology is just with the equipment rate, the NIR ProxiMate or NIRFlex rate or NIR online, when read at sample, it's not just one parameter, because in our case, when you rate, for example, when you rate crude oil CPO or CPKO, you have 4 and 5 parameters at the same sample. This is not easy in other kind of methods, because you have to do the conventional methods like softlet that they will take 4 or 5 hours, and another kind of methods. This implies that you use more people and more equipment and more reactives, and then you have just one equipment that for each sample that you can rate, and you could have the many parameters as you can do the reference methods as possible at the laboratory and your laboratory. And this is another flexible advantage of this kind of technology.
Thank you very much. Thanks a lot. And another question to Dr. Hartel: can NIR equipment be used outside in an open area?
Okay, well, that's an interesting question. I mean, normally, and most NIR equipment, I think it's fair to say that almost all NIR equipment, including the ProxiMate and the N500 instruments that we presented here, should ideally be used indoors. I think that if there was a particular requirement to measure outside in an outside area that was completely unshielded, I think that probably the best option there would perhaps to be used the NIR online sensor that Cesar mentioned in his presentation. And those sensors would be usually used over perhaps an area of conveyance, maybe a chain conveyor or another conveyance type of system, where they could be then mounted over the sort of enclosed area. And the reason for that is actually solar radiation, on very strong solar radiation, would potentially cause issues with NIR measurement in all NIR instruments. So I think ideally, if the instrument has to be used outside, the NIR online instrument would be the best. If there is any way of shading the instrument at all, and it can be quite a temporary structure, then the ProxiMate or the N500 could be used in those areas.
Brilliant, brilliant. Thank you very much. And question to Mr. Ronhell: how reliable have you found NIR measurement of oils?
As I can talk about the closing the gap, about this economic profit could be 20%, 30% of the cost of maintenance of CPU pressing machine or CPU pressing machine, or just 1 month. If you could expand for year, this is a high reliable technology that I think that we will make important development of the panel mills that they could use for measure your oil losses. This all for the next for the closing this gap. All you can do about the closing this gap is the way for optimize the production and get a continuous improvement with this kind of equipment, NIR equipment.
Thank you very much. Thanks a lot. And Mr. Hartel, Dr. Hartel, we are interested in NIR. This is another question from the registration form.
Okay.
Is it possible for the equipment to calculate a dry basis conversion from a wet basis calibration?
Right, okay. In this case, it is with the ProxiMate. There's an inbuilt function that allows to do dry weight conversions. So when you set up an application within ProxiMate, you're able to set up an as-is or dry basis, or in fact, there's a number of built-in moisture options. I think 10, 13, 14% moisture options are also available. So there's a built-in dry basis conversion inside the instrument. If some other type of conversion is needed, then it's possible to set that up manually using the calculated properties parameter, where a user is able to effectively add their own equation to work on the output of the calibration.
Great, thanks a lot. And another question to you. Currently, I have a BUCHI NIRFlex N500 that I purchased for analysis of powders a few years ago. can I convert it to also measure oil?
Okay, right. Yeah, no, that's a good question, isn't it? I mean, yes, is the answer, because of course Cesar has shown that he's able to measure palm oil products using the NIRFlex M500. I suppose really it depends on the exact setup of the customers, whoever N500 that is. But I suppose in this case, it would be possible to purchase things like the applications that we have available, and you'd be able to use those to get you started immediately. And it may also be a case that you might need to purchase some of the additional accessories that I mentioned, perhaps to help convert the instrument to the to measure the oil. So things like transflectance adapters and perhaps the right measurement cell. It's difficult to say on a general question like this, but yes, is the answer. It would be possible to convert the instrument very easily to do that, yes.
Great to hear that. Thank you very much. And another question to you, do I need to develop a calibration for each product?
Okay, well, I suppose as we've shown, there are calibrations developed. Sorry, I'm getting a bit dry. There's calibrations already available for many products. These ready-made calibrations are usually used with a minor adjustment to get them working. But I suppose where applications or calibrations aren't available for products, maybe there are some intermediate products that we haven't covered yet, it would be necessary to develop a calibration for those products in those cases. As you can see, we're working on quite a few different products as it is, but there could be a case where a calibration would be needed. As I said, with the ProxiMate, there's a number of application development or calibration development tools. And again, with the N500 instrument, I don't think I mentioned, but there is a calibration development suite there that would allow you to develop calibrations where they're needed. But as I say, there's quite a comprehensive set of calibrations and applications for palm oil industry as it stands, and that's growing as we work with it.
Thank you very much.
Okay.
And another question, what other food products can be measured using the NIR technology?
Wow, okay, that's a very, very broad question, isn't it? I mean, I suppose it's widely known that NIR technology was originally developed to measure grains. I think it was the Canadian Grain Foundation that originally did the work on developing NIR technology for foodstuffs. But yeah, in addition to edible oils, I mean, BUCHI has quite a lot of experience in dealing with other industries. We've worked quite extensively with the meat processing industry, for example, flour milling and other milling industries, grains, and dairy industry as well. So there's quite a big range there of other food products that NIR can be applied to and successfully applied to as well and used for routine analysis.
Thank you very much. I expect that whenever the customer has this kind of question, can just go directly to BUCHI just to check.
Yes, quite. It is quite a general question.
That's all right. Thank you. Another question, can you share any specific food industry examples of NIR measurement? I think you've done that a little, but maybe something really interesting, something unusual.
Yeah, I mean, I guess recently I was at a meat processor, for example, where we make measurements of ground meat. The customer has an interest in measuring moisture, fat, protein, and connective tissue in meat. And that knowledge of those parameters allows them to optimize their process. It helps them, for example, reduce the amount of lean meat that they give away in some of their products, such as beef burgers or sausages, etc. That's quite a big thing here in Switzerland. And yeah, I suppose meat would be a good example of one of the recent examples I've dealt with. Yeah.
Thanks a lot. Will the paper that Mr. Cesar mentioned in the presentation, will it be available in English language? How about that?
Yes, I mean that's something that we're working on at the moment. Actually, the papers with the translators. It's not quite. Unfortunately, we were hoping to get it done for today, but it's not quite finished. So we will email everyone who's been registered for the webinar an English language version of the paper. And as Cesar, I think, is probably itching to mention, there's a link to download the Spanish version if you wish to do so. So you can choose your language. I think most of the palm oil producing areas can either, maybe second language, but either English or Spanish usually covers the majority of those areas. Okay, so look out for in your email box for the English language version in the coming days.
Great, that's a great information. Cesar, would you like to add something to that?
I will. This experience for us, for Cenipalma and the Colombian palm oil mills, is open a new horizon. Is breaching these old paradigms about the quality, about the losses. I think that this is the new way that we must continue exploring. And I would like to invite another palm oil mills or refineries to see this kind of technology, because this kind of the challenge by the COVID-19 and other opportunities, we have to improve. We have to make decisions at time. I think that this kind of the approaching of the technologies is the good way. Is the new north about the research, about the profits. We are searching at the palm oil mills every day.
Okay. And on the basis of your expertise, I think there's another question for you, Mr. Ronhal. How much training do the plant operators and palm oil lab staff need to get started with the instrument?
Okay, when I go to a new palm oil mill with Natalia Forero, and we just talk 2 hours, 3 hours for make a teaching and training about the NIRFlex or ProxiMate. It's very easy. It's very easy because the NIR ProxiMate have all the results that you need to make a series of the measure and prediction. It's no difficult, because this equipment, especially the NIR ProxiMate, is all-in-one technology.
All right, thank you very much. Sounds really quick. Sounds great. Okay, and Mr. Dr. Hardell, once again, is it really possible to wash the ProxiMate with a high pressure hose? We have had other equipment fail when we have done this in the past. How can you be sure that the instrument will be okay?
Well, we hope. Well, I think during the development of ProxiMate, it underwent quite a lot of testing for us to be able to offer this functionality to the market. You know, it was certified to the IP69 standard, which is, as I said, the highest that's available. I can say, really, you know, the ProxiMate was launched over 2 years ago, and I know many of our instruments are placed in quite harsh environments where they have been washed down on a regular basis by customers. At the moment, you know, we haven't seen any failures whatsoever with regards to the instrument washdown. So I'm pretty confident after 2 years. That's a good record. I mean, of course, it's dependent on the servicing, and we do recommend an annual inspection and service for the ProxiMate instrument to ensure that the waterproofing is still intact. And as part of the annual servicing, there would be a leak test to ensure that the instrument would still be completely airtight. And so I think that's very important that people do that, just to ensure that the instrument doesn't get damaged over time. So it comes down to servicing, and it comes down to instrument design. I think it means that we can be sure.
Great. Thank you very much. Can NIR able to test phosphorus soap and anisidine value. I hope I pronounced it well.
Okay.
How about that?
Okay. And for any parameter, it's necessary that wavelength response is into near NIR range. Some of these parameters, like anisidine, could be trained like a prediction model of NIR ProxiMate or Flex. It's important that the reference methods of AOX, manual or another standard for laboratories could be applied over the same kind of sample of NIR equipments. This is the last answer is possible.
Okay, thanks a lot. And another technical questions. What will be the possibility of using NIR to measure total chlorine, MCPD, and GE in the edible oils?
Okay. We are at Cenipalma, we have a reference method according to the standard methods and Malaysian methods for identification of 2 and 3 MCPD and glycerol ester. Because the standard method for this kind of parameter is not easy. In the future, we will work on this parameter determination, testing, or using the NIR equipment, because the low molecular vibration of chlorine and other special conditions for sample preparation are required. It's not just take an oil sample and put on the NIR. We have to make previous procedures to use this kind of technology on NIR equipment, and it could be possible, but I saw out to the future.
Thanks a lot, thank you. And I think another one, last one. Can NIR measure TBARS and unsaponifables?
Okay, this is more for refination area, but at Cenipalma we have not analyzed this kind of parameter yet. But I will suggest that research is important features of these parameters can be found into the near wavelength range. Okay? This is the more important, that the substance and the molecular configuration like carbon, hydrogen, and oxygen is present. Then the wavelength response is into the NIR range.
Would you like to summarize the meeting today, Mr. Rangel, with those information? We have it here, like just briefly say what people can get from those websites.
Okay. Yes, this is the website for BUCHI and for Cenipalma. And Cenipalma website, we have an important mission. We show about the truth, about the myths of the oil palm around the world. This is the YouTube site of the La Palma es Vida, Facebook and Instagram site. You can see any moment comments about this. Thanks for the invitation to this webinar. And you will to know more about the Colombian sustainable oil palm myths and truths about our guild. Please visit this URL. And finally, in name of all Colombian oil palm growers and Cenipalma, we appreciate this opportunity to show a big advance of this agro-industry for the world. This is my last comment.
Great, thank you very much. So once again, thank you all, and goodbye. Thank you.
Thank you.
Bye. Goodbye.
Goodbye.